All right, let's just jump right in. Your body, it's just this incredible piece of engineering, right? A self-regulating system doing millions of things you don't even have to think about. Well, today we're going to zoom way, way in to look at one of the most amazing little machines you've probably never even seen. So deep inside you, you've got two of the most advanced purification plants on Earth, your kidneys. And their job? It's nonstop. They're filtering your blood 24/7. But have you ever stopped to think about just how much work that actually is? Okay, get ready for this number. Every single day. Your kidneys filter somewhere around 180 liters of fluid from your blood. I mean, to put that into perspective, that's like 90 of those big 2-liter soda bottles. All of that every 24 hours. It's just wild.
So that leads to the big question, right? How in the world can a couple of organs, each one about the size of your fist, manage that insane volume with such precision? Well, the secret, it's found in a microscopic masterpiece.
So let's zoom in. If the kidney is the purification plant, think of the nephron as the individual worker on the assembly line. It's the tiny functional unit that's doing all the real heavy lifting. So if you look here, you can see each nephron has two main parts. First, you got this little ball-shaped thing. That's called the renal corpuscle. That's the main filter. And then, coming off of that, you see this super long winding tube. That's kind of like the processing center. So yeah, to put it simply, the nephron is basically the tiny workhorse that filters your blood to make urine. This is where all the magic happens. Separating out the garbage from all the good stuff your body absolutely has to keep. And just think about the scale of this for a second. We're talking over 1 million of these little filtration units packed into each kidney. It's that massive number, that sheer volume of workers that lets your body handle that crazy 180 liters of fluid every single day. All right, so let's follow the journey, shall we? Step 1 is what I like to call the great filtration. This is where your blood gets its first really intensive, deep clean. Now, this part is really key. Blood flows into the filter through a tiny artery, an arteriole, and it leaves through another one. Just picture 2 narrow pipes. This whole setup creates a super high pressure zone that literally squeezes fluid and all the waste products right out of the blood. And this image here, it shows that high pressure zone perfectly. That little tangle of capillaries you see in the middle, that's the glomerulus. It's basically a high pressure sieve. And it's wrapped in something called Bowman's capsule, which is like a funnel, just catching everything that gets forced out. Okay, let's zoom in even more. What you're looking at here is an electron micrograph of the filtration barrier itself. And yeah, it looks complicated, because it is. This is not your simple kitchen coffee filter. We're talking about an incredibly sophisticated, multi-layered molecular sieve. So this barrier, it works in 3 steps. First, you've got pores in the capillary wall itself. They're just big enough to stop things like red blood cells from getting out. Step 2 is a basement membrane, which is kind of like a fine mesh that stops big proteins. And then finally, you have these really cool specialized cells called podocytes. They form a 3rd layer with these tiny little slits that catch any medium-sized proteins that might have slipped through. By the end, only water and the really small stuff can make it past this triple-layer security system. Okay, so at this point, we've collected the first batch of filtrate, right? It's a mix of water, salts, sugar, and, of course, waste. But wait a minute, our body can't just toss out all that good stuff. And that brings us to the next crucial stage, the renal tubule. This is where the real sorting and recycling kicks in. The best way to think about this long tubule is like a really smart recycling conveyor belt. As that filtrate flows along, the body is busy pulling back all the good stuff it needs: water, glucose, important salts. This whole process is called reabsorption. And at the same time, it can also dump a few extra waste products directly into the tubule. That part's called secretion. And the efficiency here is just mind-blowing. Out of that massive 180 liters that gets filtered in the beginning, over 99% of it is reabsorbed back into your body. Yeah, 99%. This amazing recycling process is what turns that huge volume into the, roughly 1.5 liters of urine you actually get rid of each day. But wait, there's more. To make this recycling process even smarter, it turns out the body doesn't just have one type of nephron doing the job. Nope, not all nephrons are the same. You've actually got 2 different types. Think of them as a team of generalists and specialists. If we look at this diagram again, you can totally see the difference. The one up top, that's a cortical nephron. See how its loop is pretty short? But the one on the bottom, that's a juxtamedullary nephron. Its defining feature is that super long loop that plunges way down deep into the inner part of the kidney, which is called the medulla. And this table here lays it all out perfectly. Those cortical nephrons, the short loop ones, they make up about 85% of the total. They're the workhorses handling most of the general waste removal. But that other 15%, the juxtamedullary ones, those are the specialists. That super long loop of Henle is absolutely essential for making concentrated urine, which lets your body save water when you're getting dehydrated. And you know what's really cool? The whole system is brilliantly self-regulating. By tightening or loosening the in pipe, that's the afferent arteriole, or the out pipe, the efferent one, the nephron can totally fine-tune the pressure inside that filter. So if the pressure needs to drop, it can squeeze the in pipe. If it needs to go up, it squeezes the out pipe, which kind of creates a little traffic jam and forces the pressure up. It's an amazing, dynamic, real-time control system. So, okay, we've gotten pretty deep into the nitty-gritty mechanics here. But why does any of this matter? Why is this tiny machine so important? Let's pull back and connect all this to the big picture, your actual everyday health. Look, this isn't just about making pee. What these nephrons do is literally life-sustaining. They're constantly clearing out waste products that would otherwise build up and make you feel awful. They're fine-tuning your water and salt balance, which is the key to everything from hydration to energy levels. They even help control your blood pressure and switch on vitamin D for strong bones. I mean, they're basically master chemists working 24/7 to keep your body's internal environment perfectly balanced so you can just live. And this whole incredible, complex process, it's happening inside you right now. A silent, nonstop, microscopic balancing act. So, the final thought I want to leave you with is this. Now that you know just how hard these millions of tiny machines are working for you, what's one simple thing you could do today to help them out?